Good morning, Mr. DC is here. In another one today we're going to talk about special right triangle. There are two special right triangle, 45, 45, 90, 30, 60, 90. So when you have those two triangles, you can still use Pythagorean theorem. However, it's going to take you more time. So those two special triangles has special shortcut properties. If you are aware of those, you will answer those questions just like that. Those special triangles. Notify them whenever you have a right triangle. You still have the right to use Pythagorean theorem, trigonometric ratios. However, if it's a 45, 45, 90, there are certain shortcuts you can take that will make your life easier. If it's a 30, 60, 90, there are certain rules, there are certain properties you can apply that will make your life easier. Let me show you what I mean by that. If you have a right triangle, which is 45, 45, 90, right? And this is 45, 45, this is 2, this is 2. In this case, this triangle is right isosceles. Now, if you did not know from prior knowledge, if you know what you're doing, I can predict the answer, what the answer will be. It will be 2 square root of 2. I don't have to do anything because I know certain properties based on that. For you may not know those properties, then you will have to use Pythagorean theorem, which is a squared plus b squared is equal to c squared. Now this will be your c. This is the hypotenuse because it is opposite to the 90-degree angle. Those are your legs. The legs are the same. That makes it right isosceles. So you will have to do 2 squared plus 2 squared is equal to c squared. Right? This will give you 4 plus 4. Now instead of adding 4 plus 4, you don't want your answer to be in decimal. 4 plus 4 is 8. There's another way you can add that to get 8 is 4 times 2. Now, since you don't want to deal with decimal, then you will have to take square root of each one of them. Then you will see that square root of 4 is 2. Then your answer will be 2 square root of 2. You don't have to do all of this square if you know what's going on. So let's do certain answers again. Right? What we need to notice that when the legs is 2, they are the same. Alright? The hypotenuse will always square root of 2 times the legs. Right? When the legs are the same, you see right isosceles 45, 45, 90, you will see that everything has a 2, but the hypotenuse will be 2 square root of 2. So if I create another triangle, you just need to observe. It doesn't matter. The legs are 3. As long as it's 45, 45, 90, I can predict what the hypotenuse is going to be. It will be 3 square root of 2. You don't have to do anything, it's common sense. Now in this case, I will have to do 3 squared plus 3 squared is equal to c squared. Then this will give me 9. This will give me 9 also, but I will not add 9 plus 9. I will multiply 9 by 2 instead. That will give me 18, which is the same thing. That's a smarter way to write it. Then you will have to take the square root of that, and you will see that c is equal to 3 square root of 2. As I predict earlier, I don't have to do anything. So as long as the legs are the same, see 3, 3, the hypotenuse will be 3 square root of 2. Take the legs multiplied by square root of 2, will get your answer. Right? That's what the reason it's called it shortcut. As long as it's 45, 45, 90, the legs are the same. Just take the hypotenuse multiplied by square root of 2, you'll get your answer. As you can see here, it will always work. If this is 5, this is 5, the legs are the same. I don't need to waste my time to use the Pythagorean theorem to find c, which will be 5 square root of 2. Right? Because as long as the legs are the same, and this is a 45, 45, 90, and it will always be that. those are the same. Those two angles will always add up to 90. If you take 90 divided by 2, those angles will be 45. This will always be right isosceles triangle. To prove that this will be 5 square root of 2, you will take 5 squared plus 5 squared is equal to the hypotenuse, which is c squared. Then you will end up with 25. I don't need to do 25 plus 25, so I can rewrite it as 25 times 2 instead of getting 50, because if you add the 25 plus 25, you will have the thing of use calculator to get the answer. You don't want those answers in decimal, so you will have to take the square root of each of those numbers. Then you will see this square root of 25 is 5, and the square root of 2 stays. So when you take your FSA, they want your answers to be in radical, no decimal. As you can see, doesn't matter if I change the number or not. Alright? As long as it's a 45, 45, 90, this is a 45, 90. You don't need to use the Pythagorean theorem because it's gonna take you more time. So let's do another one. Then I'm gonna try if I can trick you. Based on that, we're gonna use a formula to that. These are your 45, 45, 90. This is 6. This will be also 6 because it's an isosceles triangle. The letters are the same. If this is 6 and 6, I can predict that the hypotenuse C will be 6 square root of 2. So that will be 6 squared plus 6 squared is equal to C squared. You will end up with 6 squared is 36 plus 36. Some of you are going to add it, but I will add it to see what's going on. You will have 72 is equal to C squared. Then you will have to take the square root of that. So that will be more work for you. So you will have C is equal to square root of 72. Some of you will stop or use the calculator to change that to decimal. That's wrong. So as you remember last lesson for when we're using Pythagorean theorem, you have to simplify that, find the perfect square instead of 72. So 72 is 2 times 36. As you can see, 36 is 6 times 6. This is you get the perfect square. 6 times 6, 36 is the perfect square. Then you will have 36 times 2 is equal to C. Then you take square root of each one of them. As you can see, that C will be 6 square root of 2. What I'm telling you, what I'm trying to convey to you, as long as you realize it's a 45, 45, 90, the legs will be the same. The hypotenuse will be 6 times the leg, whatever the leg is, you multiply by square root of 2. The hypotenuse will always be whatever the legs is, you multiply by square root of 2, that will be your hypotenuse. You don't have to go do all of those Pythagorean theorems. Those are time consuming. So as long as you notice the 45, 45, 90, then you can use those special rules. Alright, let's do another one, then we can generate the rule, then we do some application. So as you can see that if my triangle if this is 10, the legs are the same, this has to be 10, and if you take 90 divided by 2, those will be 45, 45, 90. Then this is one of the triangle. Now, by now, you should know you don't need to do anything. The legs are the same. As you can see, the hypotenuse should be 10 square root of 2. That's our answer. But if you don't believe that, then you can use the Pythagorean theorem. You will take whatever the legs is, 10, you square it, plus 10 squared is equal to the hypotenuse squared. Then you will end up with C squared is equal to 100. Like I told you later, you don't have to add 10 plus 10, 100 plus 100, that will give you 200. Just take the 100, multiply it by 2, that will also give you 200. Now you can take the square root of each one individually. And as you can see, square root of 100 is 10. The answer will be 10 square root of 2, as we predict earlier. So the moral of this story, as long as you determine that it's a 45, 45, 90, you don't need to do anything. Just take the legs multiplied by square root of 2, you get the hypotenuse. So based on that, we have developed a pattern based on 45, 45, 90. Then we can generate other formulas from that. So let's create some formulas, then you will be in the game. So when we were finding the hypotenuse in the 45, 45, the hypotenuse will always equal to the legs, whatever the legs is, you multiply it by square root of 2. That will give you the hypotenuse. Now, not all the time they will give you the legs. It can give you the hypotenuse. Alright? Once they give you the hypotenuse, then you will use that the other way, the inverse of that. So if they give you the hypotenuse, then you want to solve for the leg, you will have to divide. So you will have hypotenuse equal legs, let's use x for legs, times square root of 2. Okay? We just substitute x for the legs because the legs can be a number, it could be an x, a variable. Now, if I want to solve this problem, I will have to solve for x. You see, when you're looking for the hypotenuse is always equal the legs times square root of 2. Now, if I want to find the legs, which is x, I will have to divide both sides by square root of 2. We have to do the inverse. Therefore, you will end up with x equal whatever the hypotenuse is. They will give it to you as a value or as a variable over square root of 2. All along, there's a rule that says you cannot have a square root as your denominator. In this case, you have to rationalize your denominator. You have to clean your denominator. In this case, in order to clean that to make it a perfect square, you're going to multiply it by itself. If you multiply your denominator by square root of 2, you have to multiply your numerator by square root of 2. In this case, you will end up with hypotenuse times square root of 2 over square root of 4. Square root of 4 is 2. Then you will end up that. So whenever you're looking for the legs in the 45, 45, 90, you will have to take the hypotenuse, you multiply by square root of 2, you divide it by 2. So this is the rules that we have developed. Now we are ready to do some application. Let's see if you can get tricked. Let's see if you understand what's going on. So not all the time they're going to give you the legs, sometimes they're going to give you the hypotenuse. If they give you the hypotenuse, to find the legs, you have to do it backward. Take the hypotenuse, divide by square root of 2. However, you cannot have a square root as your denominator. You must multiply your denominator by square root of 2 and your numerator by square root of 2 to rationalize your denominator. So let's see if we can do some application now. Hopefully we have some knowledge. Alright? Go over those rules, and this is really important in trigonometry. So when you're taking pre-calculus, algebra, you're going to see more problem in that. Alright, you have a problem that goes this way. This is 45, and this is 4. This is x, this is y. We're finding x, we're finding y. In this case, this is a 45, 45, 90. As you know, in the 45, 45, 90, it's a right isosceles triangle. Therefore, the legs will always be the same. That's the easiest thing that you have to know. You have to know what y is. Those are the same. Therefore, y is equal to 4. Right. This side will be 4. Based on what we did earlier. So when you're looking for the hypotenuse, in this case the hypotenuse is x. That you will have x equal, the legs is 4. Then you take 4, then you multiply by square root of 2, then that's your answer. X will be 4 square root of 2. If you don't believe that, you will have to use Pythagorean theorem, which is 4 squared plus 4 squared, which is what we were trying to prove earlier. Then you will have 16 times 2 is equal to x squared. Then you will have to take square root of each one of them. then you will see that x is equal to 4 square root of 2. So you don't have to do all of that. Since you realize that it's 45, 45, 90, you could have only just take the length multiplied by square root of 2, then you're done with this problem. As long as it's 45, 45, 90, apply those shortcut rule, then you will be able to get your answer just like that. Alright, let's do other one. You're all the same, just apply the rules. Y, X, right? This is another one, 45, 45, 90. The legs are supposed the same. This is the hypotenuse. So, in this case, the legs is 5, they are the same. So this should be equal to that. Therefore, in this case, x is 5. This will be 5. And it's telling you to find the hypotenuse, take the legs multiplied by square root of 2. Therefore, the hypotenuse is y. And you say y is equal to the legs, which is 5, times square root of 2. Then you're done. Right? That's the 45, 45, 90. So let's see the big one where it's getting more complicated. All right. This is when they give you the hypotenuse, then you have to find the legs. That will be the opposite of what we've been doing. Now they're telling this is 8, this is x, and this is y. Okay. Now we know what the hypotenuse is. We don't know what the legs are. The legs are missing, and the legs are supposed to be the same. I will show you the short way, and I'll show it the long way. This is why you have to pay attention in class. Right? This is a tough problem to many of you because it's the indirect. So my hypotenuse is 8. I'm looking for x or y. You have to know x and y are the same. X is equal to x. Then I can substitute wherever I see x, I can replace it by y. Alright? Or wherever else, then I can let y is equal to x. Therefore, x is equal to x. Alright? Now, let's go in that rule. It says the hypotenuse is 8. Right? Then I'm going to have 8 is equal to the legs, which is x, times square root of 2. That's our equation by using substitution. I just substitute 8 for the hypotenuse, x for the legs, and I'm solving for x. In this case, I have to cancel my multiplication by division. I have to divide both sides by square root of 2. And this will cancel with that. In common sense, you will end up with x is equal 8 over square root of 2. However, you cannot have a square root of 2 as your denominator. You have to rationalize your denominator by get rid of that square root. Therefore, you have to multiply this by square root of 2. If you multiply your denominator by square root of 2, you have to multiply your denominator by square root of 2. Then you will end up with x square root of 2 over square root of 4. Square root of 4 is 2. Now this is your solution. However, you have to simplify that. As you can see that 8 is divisible by 2. 2 goes to 8 4 times. Then you end up x is equal to 4 square root of 2. And remember x is equal to y. Therefore y is equal 4 square root of 2. You're done. You're done with this problem. Otherwise, there you go. What you will have to do if you are using Pythagorean theorem and you will see it more difficult. The shortcut, that's what you do. You use the formula, then you replace that. But if you were not using the formula, then you have to come here telling yourself that x is equal to y. By substitution, wherever I see y, I can let x be there. Wherever I see x, I can let it be there. And in this case, I will have to use the Pythagorean theorem. You will see how this problem becomes very difficult. In this case, if I'm using Pythagorean theorem, I will have x squared plus x squared is equal to the hypotenuse squared. Then I will have that. Then I will end up x squared plus x squared is 2x squared is equal to a squared, which is 64. Since I'm solving for x, I will have to divide by 2. Then once I divide by 2, I will have x squared is equal to 32. My next step is to take the square root of each one of them. Then I will have x is equal to square root of 32. As you can see, guys, if you get up in there, you will have the intention, you will think a calculator is the solution for you. In this case, you cannot use the calculator. You can use the calculator to do factor tree to find the biggest perfect square inside of 32, so you can simplify that. So when I'm doing my factor tree, 32 is 2 times what? Is 2 times 16. 16 is 4 times 4. As you can see, I have a perfect square. 16 is a perfect square. Therefore, I can rewrite square root of 32 as 16, square root of 16 times square root of 2. What is the square root of 16 is 4. Then the answer is 4 square root of 2. We'll have to do all of those crap to get to that answer. Otherwise, I'm telling you, you don't have to. You can do it the easiest way by doing that. This is a lesson that we are trying to convey to you. If you realize at the beginning it's a 45, 90, you can use the special rules to make it much easier for you. So that was Mr. DC's in special right triangle. Then we come in later, so to go on the